9.6 probability. Okay, we are going to talk about finding different types of probability, experimental probability, and some different stuff. Any happening whose result is uncertain is called an experiment. That would be experimental probability when it's uncertain. The possible results of the experiment are called outcomes, and the set of all possible outcomes of the experiment is called the sample space of the experiment. Any subcollection of sample space is called an event. So, for example, find the sample space for each experiment. A coin being tossed. A coin is tossed. What would be your options for a coin being tossed?
50-50.
So if it's experimental probability, you're saying that it's 50-50. Yes, you could get heads or you could get tails.
What's the bean? You say corn bean? Coin bean?
The coin being tossed.
Coin toss.
Oh, coin bean.
Sorry.
Not bean.
What is the probability of 2 coins that are tossed?
Isn't it still 50-50?
No.
25.
Yes. Here's why. 2 reasons why. If you do 2 coins, the first coin could go heads, right? The second coin could go tails. The first coin could go heads. The second coin could go heads. The first coin could go tails and then heads, or tails and tails.
What
So-
happens if it lands on its side?
Exactly.
7.
Okay.
Samson question.
So my sample space shows that it's heads, 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 tails, tails, heads, tails, tails. So it distinguishes between the 2 cases of heads, tails, and tails, heads. Even though these 2 outcomes appear to be similar, they are not. So for 2 coins being tossed, you have a 25% chance of figuring out which method it would be. What about for 3 coins that are tossed?
15.
Well, you could go heads, 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 right? You could go heads, heads, tail. We can just change one at a time. You could go heads, tail, tail, right?
Yeah.
Heads, tail, tail. You could go tail, tail, tail. You could go tail, heads, tail. You could go tail, head, head.
There's a lot
Here's
of
the-
probabilities.
No, we didn't. We didn't go tail first and then head, head. We went head, head, tail. There's a there's this.
You can go head, tail,
Distinguish.
head.
You can go
Tail, tail, head.
tail, tail, head. Yes.
Where is it?
We already did that.
No, we didn't do that one. We went head. Tails.
No, it's not the same thing.
Ian did
Because
head,
it's the
tail,
order
head.
that you throw it in. It matters. The order matters.
You forgot that head, tail, head.
Head, tail, head. Yes, you are correct. Head, tail, head. Is there anything else? Yes, probably. Did we do tail? Yeah, we did. We did tail, tail, tail. We did tail, tail, head. Yes. We did tail, head, head. We did head, tail, tail. We did head, tail, head, 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 tail, head. And we did head, head, tail. No.
Yeah.
Oh yeah,
Head,
there.
tail.
Head, head, tail. And then we did head, head, head.
Head.
2, 4, 6, 8. Yes. Perfect. And so those are all your options. So on some things you're gonna list things tonight. On some things we can just multiply numbers together. We're gonna talk about that. The probability of an event. Okay. If an event E has an N of E equally likely outcome, and its sample space S has an N of S equally likely outcome, then the probability in event E is given by. So if I want to figure out the probability of an event, okay, it equals the it equals whatever my event's likelihood is over the options that I have. So the likelihood of that happening over the total options of it happening. Okay. If your probability of your event is 0, then an event cannot occur. It is an impossible event. Makes sense. Okay.
What is it impossible?
If your event comes out to being 0. If this came out to 0, then the event is impossible to happen. It cannot happen. Okay. So let's talk about this. Finding the probability of event. 2 coins are tossed. What's the probability that both land heads up? Okay. What's the probability that both land heads up?
What's the negative? Does that mean it's impossible?
No, you can't have negative. Probability both land heads up. Okay, how can I figure out what the probability is of both of them landing heads up?
Okay, so 2 coins tossed,
It is 25%, but how do we figure that out? What's the probability of the first one landing heads up?
2 coins tossed, probably both.
What's the probability of tossing a coin and it landing heads up? 50. 1 over 2, 1/2, right? The probability of another coin landing heads up when you flip it is 50. If I multiply 1/2 by 1/2, what do you get?
1/4.
You get 1/4. And that is how you get the 25% chance. Okay?
That's it?
That's it. You multiply the probability of both of the event 1 happening by the probability of event 2 happening, and you get the probability of the overall happening. Okay? What about this? How many, do you guys know anything about playing cards? Please tell me you do. Because my geometry class seems to know nothing. It says a card is drawn at random from a standard deck of playing cards. What's the probability that it is an ace? How many cards are in a deck? 52. How many aces are there in a deck? So you would put 4 over, and you would reduce that fraction down. What's 52 divided by 4?
Wait, did you mean 1/4 when you were writing it?
Yeah, sorry. I'm being I said 25% and wrote 1/25. So what's 4 over 52 reduced down to?
23, 13.
Yeah, 1 over 13. So you have a 1 out of 13 chance of pulling an ace. Okay. These are the things I'm looking for. Finding the probability of an event. The other thing they're going to use a lot of times is dice for this, okay? So it says you have a 12-sided dice, okay? And it can be constructed in the shape of a regular dodecahedron, such that each of the numbers from 1 to 6 appears twice on each die. So you have a 12-sided die, but you have the numbers 1 through 6 and the numbers 1 through 6, okay? Instead of 1 through 12, okay? Show that these dice can be used in any game requiring ordinary 6-sided dice without changing the probability of the various events. What's the probability on a normal dice of rolling a 6? 1 in 6. Okay? So part C deals with a 12-sided die. And they want us to prove that rolling a 12-sided die doesn't change your probability as rolling a 6-sided die. Okay? So if I pulled out a 6 from a 6-sided die, I would have a 1 in 6 shot. What is your shot of rolling a 6 on a 12-sided die that has 1 through 6, 1 through 6? 2 and 12. And what's 2 and 12 reduced down to? 1 and 6. So whether you have a 12-sided die with double 1 through 6s on it or a 6-sided die, it's the same probability of rolling that number. Yes.
This is my kind of lesson.
This is your kind of lesson.
Probability.
The probability of me doing this lesson is about
That's where we're going to stop today for the probability. Tomorrow we'll talk about probability with different types of mutually exclusive events.